It's now my pleasure to introduce our second speaker of today, Sandor Caetano. And Sandor is the Chief Data Scientist at iFoods. He has 12 years experience in analysis of high-dimensional multivariate data to enable data-driven business decisions with a wide variety of expertise in the area of data analytics. And Caetano has interests in the modern application of statistical methodology and computational tools for large high-dimensional problems. iFood, if you're not familiar with them, is the largest food delivery company in Brazil with over, and I hope I have this number right, 60,000 monthly orders. And in this presentation, Sandor will show or explore the company's vision for using autonomous vehicles for meal deliveries and some very early learnings from this. So Sandor, let me welcome you to the stage for your presentation titled iFood's Vision and Learnings from Autonomous Meal Delivery.
Hello. Thank you. I'm going to talk to you about a little bit of our vision and learnings from our meal deliveries. So first, who am I? I've been working with AI for a while. For many years, I was head of data science at Nubank, also another Brazilian company. And now I'm chief data scientist at iFood. But today, even though I love this technology and I've been working with this for a while, I'm wearing a different hat. I'm wearing the hat of the business. So I'll try to make this presentation through the business lenses on how iFood looks into autonomous deliveries. So what will I cover today? So I'm going to talk about iFood, how we look into logistics today, how we see logistics tomorrow, what we learned with the tasks we did, and the vision we have for the future. Okay, so what is iFood? iFood is a Brazilian company that connects restaurants, customers, drivers, and groceries. So basically, we are a delivery company. And we've been for a while now. It exists since 2011, and it has been growing exponentially since then. We have today over 60 million orders per month, and all of those this growth came organically and also through lots of M&As we did in the past. So iFood bought lots of companies, integrated lots of companies. And around 2017, we did our first food delivery. So it was mainly a marketplace company in which restaurants came and just put their meals there. But now since then, we are doing deliveries ourselves. So about a third of all of our sales, we do the delivery. And that's where we got interested in different ways of delivering food to customers. And it's important to talk about iFood's culture to make this presentation. So iFood has a very fast culture, very entrepreneurial company, and very results oriented. So we don't care too much about failures. We don't care too much about not trying, but we always have this result-oriented mindset. And this is very important because we will do 20 different initiatives. We will fail at 19, and we will rush to scale the one that worked. And this is important when we're testing new technologies because we always have this mindset of looking into results. And if it works, we want to scale as fast as possible. But we have a problem, right? We deal with hungry customers. So people, when they open the app, they are hungry. They need food, and they need it fast, right? And we have two peaks of demand. So Brazil is not very great on breakfasts. So we have two peaks, one at lunchtime and one at dinner time. And all of our action revolves around these two peaks. So we have to be prepared to work on those two peaks, right? Not on the valleys. And also we have peaks of demand on the weekends. So Mondays are the slowest days. And of course, on the weekends are our busiest days for us. And on top of that, we have the weather, right? So if it's rainy, people stay at home and people usually order more food. So for us, a Saturday night that is raining is like a surprise Black Friday. So we have to be prepared to work on a Saturday night that is raining. And we need solutions everywhere in the company that are scalable and elastic enough to handle those situations, right? The worst thing that can happen is the time where most customers want our product, we're not there for them, right? And this is a big problem for us. So everything has to scale to this specific points. So how do we work with logistics today? As a logistic company, it's a little bit different. Last mile logistics, a little bit different from traditional logistics, in which we don't get all the orders and then we create a route to optimize, to try to, it's not only an optimization problem in which we get all the orders and we try to make the best route. Orders keep popping in almost randomly in the city at any time. So you can have an order here to a restaurant in the other side of the city. You can have an order in the other corner of the city to cross the city and have the two orders crossing themselves, and you cannot control them in time. So it's extremely unpredictable, and the system has to be able to make optimizations the whole time and extremely fast, so we can send the rider to pick up the order as fast and the right time as possible. Because missing the mark means that the riders will stay at the restaurant for more time than needed, or the food will get cold, right? So there are lots of inefficiencies in this process. And we have some modes of delivery. Of course, the biggest one is still the motorcycle. Most of the deliveries are done with the motorcycle. We use cars for groceries delivery. And we also have some other modes that we're exploring, expanding, and scaling, like bikes, electric bikes, and scooters, that not only lower our cost of delivery, but they're more green, right? But they can only work on a very small radius, right? And we are exploring a little bit with testing different modes of delivery with robots and drones. Of course, we are super interested in the right side of this slide because those are green. So iFood has ESG metrics, it has ESG goals, and our goal is to be able to deliver not only faster, not only better, but in a way that leaves less footprint. So this is our mission as a company. In terms of logistics, we're basically balancing different metrics. We're trying to keep many plates up in the air at the same time. So whenever we look at logistics, we're trying to optimize at least one or two metrics while keeping the other at least constant, right? So we're trying to maximize the riders' earnings. We want them to earn more money, right? We want to lower our delivery costs. We want to increase SLAs. We want to deliver the food at the exact time we promised you, right? So you can program yourself, right? You can plan yourself. Of course, we want riders to be productive, and we want to increase, if possible, batch size. So if a rider can make multiple deliveries from one restaurant, it's better for us, not only because it lowers costs, but also because it lowers average delivery time for everyone. So, and we look at many more metrics. We try to balance them all. And this is, of course, is an optimization problem with lots of help from AI, right? So we have a simulator in which we can replay days. So we can replay, for instance, Mother's Day. How would be Mother's Day if it had rained? How would be Mother's Day if it had twice as many riders? How would be Mother's Day if you have half the riders to do the deliveries? And then we use those simulations to improve our systems, to improve the parameters, and to learn more. Once we have a better set of parameters and models and optimizations, we do switchback tests. So we send those new developments to 2 or more cities in which we keep switching the tests to confirm, to basically validate the hypothesis we had on the simulator, And after those switchback tests, we go for full scale. So basically three process, and we run this daily, right? So we're always trying to better ourselves, to better our systems using these two steps. So how is it in iFood? So we have more than 20 million monthly deliveries. We have new modes added frequently. And of course, we are only interested in stuff that can scale, right? If it is not scalable, it doesn't matter for us. And of course, it has to have a deep integration with technology, right? So your customers have an app, the riders have a different app, and the restaurants have an app. All of those have to be integrated, and it has to work seamlessly. So it has to be great, because if it's late, everyone, the customer is sad, the food is cold, and it's not good enough for us. So let's talk about logistics of tomorrow. So we're testing on drone delivery. We did some testing with drone delivery. And what we did was, in a shopping mall, we got the food from the shopping mall. We had like a drone port in the mall. And then the drone had to fly over some green area to a house condominium, right? It was basically, in this testing, a 450-meter route, and it was basically a 3-minute flight from each one. And just because of that, just on this test, we're able to reduce the delivery time by 9%, even with the hops, because you had to have people like putting the order in the drone, and then the drone had to fly, and then you have to have another person to pick up the order from the drone port in the condominium to deliver it to people. It added entropy to the process, but all in all, it made the process faster, which was very good for us. Another test that we're doing is with a delivery bot, which we call Ada from Sandor. And we did tens of deliveries inside our shopping malls. It was a route inside of the shopping mall, but it was a 12-minute run. So it was slower than a person picking the bag and running or walking inside of the shopping mall. And we had a high intervention rate. So lots of times we had to intervene in the route with the bot, mostly because kids were interacting with the bot. So there's this novelty effect of a car running on a mall, right? So we had this example where the kid, it's like a baby, looks into the car and goes straight into it, and the car has to slow down and stop because of the kid, right? So it has to account for those little obstacles, right? The second one is the bot's running on the mall, and then there are kids running with little cars, right? And this kid, it goes and cuts right in front of the bot. So we had to do an intervention. And it's interesting, this kid should go to jail. We should not do this to a poor little bot, right? So every time this kind of stuff happens, it slows down the process, slows down the bot. We have to have an intervention sometimes. So we have to account for that. And then we have problems, of course, with COVID, shopping malls closed, and basically slow down 1 year and a half on all of our tests. So we're resuming tests now, which was sad. We basically lost this year and a half because of that. And what did we learn with all this process? Well, having a landing spot, it has to be a very clear landing spot. High walls were interfering with the GPS on the drone. We built the drone ports next to a heliport, so whenever a helicopter came, we had to stop our test, which delayed deliveries. It was a mess. So it has to be a clear spot to do the landing. Well, flight time was very precise. We had only trouble with landing and winds, right? So we derailed a little bit. It was very precise. One problem that we had was having different restaurants or random restaurants serving with the drone was bad for us because we could not control the package size. So basically we had to sort package sizes that could fit into our bag to be delivered with the drone. was not very good. So controlling this is a good idea. At first, the bag was returnable. This was a mess in terms of use for customers. So we basically built another one that was a cardboard one. So it was even lighter and recyclable. So it was better for delivering with drones. But it's not rainproof, right? So the drone is rainproof because of the new fuselage we built, but the package is not. We had, of course, lots of troubles with laws and regulations. I think this is the biggest limiting factor. And it's not moving and will not move in the pace we need for innovation. And one optimization that we did was having a dedicated person just to pick the orders on the drone, and that increased the number of orders we were able to deliver in 1 hour. The jury is still out on this one. I think it would be better if we had a process, but this is novel, so I think learning was the most important part on this. For the delivery bot ADA, right? So a shopping mall is extremely complex environment to navigate, right? So you have elevators, doors, ramps, and stairs. Of course, you have humans to avoid, especially the little ones. The little ones became a big trouble for us, and it's still slow, right? So it could be faster on scale, right? If you think like an ant, if you think about ants, right, or how ants move, if you have many bots, one after the other, on average, they should be faster, but this is still something that we have to test. And what's our vision for the future? So the big question is, can this work at scale, right? So this is the big question. Our operations are not continuous. We have the peaks, right? So with a 15-minute round trip, we could do 600, 900 deliveries, right, in theory. So the break even is not that far, right? Break even, if you buy one unit of bot at today's price, is not that far, right, from break even. Even accounting for Brazilian labor costs, right? So in Brazil, technology expensive and labor is less expensive. But even accounting for that, break even is not that distant. The problem is, can we sustain 1,000 orders per vehicle? Right? Can we sustain 1,000 orders for 100 vehicles, right? Or is this going to be only a niche solution, right? So if I have one bot, I can sustain lots of orders for this bot. If I have lots of bots, maybe I cannot sustain it, right? So what's the ratio that I need to have delivery people and bots to be able to scale this, right? So and what's the ratio that I should have that it can actually move the needle, right? Having one bot that is cost effective will not move the needle. Having thousands of bots might move the needle if we can do the math, right? If we can account for the way our demand is shaped. For drone operations, it's even harder, right? Because regulations says that we have to have the routes fixed, right? So for us, there are places where it could be useful, right? When you have a confusing urban setting, where you have bad traffic planning or natural obstacles, right? Like a river. But still, regulations cannot don't allow us to use on urban areas. And it's even interesting. A regulator suggested that we use nets. So let's say a drone has to cross a street. So you could use a net over the street to basically protect if the drone falls. Imagine having to build nets everywhere. So it's not only super expensive, it's also ugly, right? So it doesn't make any sense. So using this on less populated areas or places with natural obstacles seems to be a better idea. But less than 0.1% of all our restaurants fit into this criteria. So are those areas enough to justify the investments? Will this move the needle? So this is a big question for us. For autonomous cars, I think they don't have the regulations we have with drones, so they might be the potential on delivery bots are bigger, and they are not mutually exclusive, right? I could have both, but still they need lots of tech, right? They cannot open doors, they cannot ride elevators. So we could use them, for instance, in housing condominiums, right? And the question is, are those use cases dense enough? So how many orders can we have in a condominium per day? How many orders can this bot delivery, right? Is this big enough to move the needle for us? So to end this presentation, we think it's still a long way until we can use this at scale. We are optimistic, right? For niche cases, it's not that far for us. I think we can start using for real and integrating this in our systems, and could even be cost effective for a few units. But we're looking to work this at scale, right? We need actual results for this. So we need breakthroughs, significant breakthroughs in legislation, of course, specifically for drones. We need, of course, to lower costs. If the costs are low enough, this could work in scale. And of course, we need breakthroughs in tech, so the bots can, well, basically avoid kids or be more safe around kids and navigate more complex environments and faster. But this is still too early to estimate this potential impact for us. So this is what I had for today.
Thanks very much for that, Sandor. I loved how you really kind of outline what's happening in Brazil, and I'm assuming you are in Brazil joining us today. And again, a whole other aspect of COVID really allowed us to kind of use this technology, because likely otherwise you wouldn't be able to be here with us today. And I know in the last presentation, I mentioned some people might think pizza delivery on a drones is trivial, but from your presentation on the food side of it, what a great segue, because we can see that clearly there is a massive demand for this, the type of thing that you're doing, and it's really quite interesting. Just trying to look here, there's a number of questions we have from the audience, and maybe I'll just start with a couple of those if I could for you. As part of your presentation, you talked about how the pandemic sort of highlighted the fragility of the global sort of supply chain. And I wonder if you have any thoughts, or you're asked about any thoughts going forward as to, how a delivery like yours and maybe the internet really, I guess, would be key in dealing with a sort of a pandemic or emergencies like we've just experienced. I mean, do you see this as kind of the future of a lot of the food and other delivery for other items?
Okay, this is an interesting and hard question, right? So we're still in the middle of the pandemic, right? But what we saw, specifically by being a food delivery company, is that when things got really rough and people had to be quarantined at home, the demand for our services increased a lot. And so this was helped us play a role in society, right? Helping connect people, helping bring food to people to their homes, and some people even lost their jobs. So they joined iFood to do the delivery. So all in all, food delivery in Brazil was considered like what's called an essential service.
Yes.
Right. So it was very positive. It was very good to be able to be in the middle of this and helping people and helping well, at least easing the burden of the pandemic, right?
Yeah, it obviously provided a very valuable service, in this whole pandemic. And I think there's probably an awful lot of people in Canada wishing we had a company similar to yours here that could have done that. And that kind of leads to an interesting second question from our audience, asking about sort of the use of the electric and sort of autonomous type vehicles. And it would seem that using those would reduce the carbon footprint. And they're asking, did you do any surveys or any research showing what that reduced carbon footprint impact was or would be by using sort of electric drones or robots?
Unfortunately, I don't have the numbers. I
Okay.
think we're still on, is this viable, right? We have research on electric bikes versus motorcycles, but I don't have the numbers to share.
Yeah, no, that's okay. But I guess anecdotally, if the vehicles have a reduced carbon footprint, then by extension, you're using them, and more of them would definitely do that. So, as you said, moving in the right direction, providing a critical service, and in a greener way. So that's great. Someone from our audience asked, maybe Sandor, what can maybe ports or sort of delivery yards learn from the work that your company's done about the use of autonomous vehicles in this intermodal logistics, sort of last mile delivery? Are there lessons for other types of businesses from the work your company's been doing?
This is a great question. The problem is I don't understand ports and yards too
Sort
much to be able to link with food delivery. So
right. So right, language maybe thing there. Port being like a shipping port where ships would bring cargo in, and other various maybe cargo yards, maybe trucking yards where intermittently product would be stored or marshaled. Sort of the traditional, I guess, supply chain. Do you have thoughts how the traditional supply chains might start to look at adopting some of the technology or the methods you've used at iFood?
So what we do is, it's still too early, but the technology we tested, they are not fully autonomous, right?
Mm-hmm.
We have to bring the food to the drone or bring the food to the bot, and then the bot and drone has their own path, and at the end, someone has to pick the order and delivery. Right? And this we have to integrate this in the simulations, right? So I think the big leap for us is, once we can prove that those technologies can work, integrating them in the simulators and playing with the scenario. So the whole idea for us is, okay, we prove that it can work, more or less, right? Now we integrate this in our systems and optimize running simulations and with lots of use of AI to optimize the whole process. So you create scenarios, you change the modes of transportation, and you think, well, and you basically analyze what happens, what could happen in reality. Then you play in reality. Of course, you'll be wrong, and then you go back to the simulations and update the simulations, right? I think it's still, this for us is a software problem.
Okay, interesting. Yeah, that's interesting. You mentioned too regulatory as a challenge, and maybe you could expand. What were there particular types of regulatory challenges that you faced as you looked at experimenting with robots and drones, or maybe is it, as you mentioned, just the pace at which that regulatory changes? Maybe you'd say a little bit about what the regulatory challenges were, Sandor?
Well, of course, the pacing is slow, right? So we can only do routes that, of course, aren't crossing anything that is like a street or people live, and we have to have fixed points of delivery. So you have to go specifically from A to B.
Okay.
Right. So you have a system that makes the drone goes, and then it has a maximum speed that it can go, unless you have a person watching the drone. So you have to have a watcher. So this is the kind of regulation that you say, hey, maybe we don't need this, right? Or we can improve the technology. If we can improve the technology enough, we can make the case that this technology, so you could track the drones in a different way, right? Or you can even use a camera to track this. So this is the kind of regulation that is slowing us, and you have to have this whole apparatus of lots of people to make a drone fly, which of course takes off the feasibility of the project.
Okay, that's interesting. And in our last speaker, the suggestion was made that discussions with regulatory bodies were going to be important. And maybe just as a closing thought, are you sort of seeing the openness of regulators to be talking with companies like yours about the changes that you feel are needed to regulations, or how are they reacting to you?
So this is interesting, right? I said that I was wearing the business hat. From a
Mm-hmm.
business perspective, of course, we want to move fast, and we if it was up to us, we would already be delivering stuff by drones, right? But to be honest, the regulator is pretty open to suggestions, to
Mm-hmm.
working with us. I would guess that we're one of the first companies doing drone deliveries in Brazil, and they want to know, they want to be part of it, and we're working with them. Of course, there are still regulations, but it's working, right?
Mm-hmm. Okay, good. Well, thank you very much, and thank you for providing insights and sharing the information about what your company is doing. I think we'll all be watching now iFoods with great interest to see how you progress, and wishing you great success, and maybe looking forward to your Canadian expansion. So,
Really awesome.
thank you so much, Sandor. Appreciate you being with us today.